Welcome everyone. In this video, we will walk you through the two types of SQL joins. So, let's dive right in.
In SQL joins, allow users to retrieve data from multiple tables simultaneously by matching rows based on related columns. This enables users to construct complex queries that incorporate data from different tables, facilitating comprehensive analysis and reporting. The types of joins are: first, inner join; second, left join; third, right join; fourth, full join; 5, sub-join. We will only talk about the inner join and the left join. Optimizing join queries. Reducing data size. Reducing the number of columns retrieved at select clause. Doing join queries help to minimize the size of result set, leading to reduce the data transfer overhead over the network by selecting all the necessary columns. Unnecessary data is excluded, resulting in more efficient use of network resources and faster query execution. Filter early. Applying filters to the workflows before joining the tables allow database to reduce the dataset size by eliminating rows that don't meet the filtering criteria. This optimization reduces the workload of the join operation by processing only the relevant rows, leading to the faster query execution and improved performance overall.
Avoid Cartesian products. Specifying join condition accurately is crucial to prevent Cartesian products, where every combination of rows from the join table is returned. Cartesian products can lead to exponentially large result sets, consuming excessive resources and severely impacting performance. By ensuring precise join conditions, only the desired relate rows are combined, avoiding unintended data explosion and maintaining efficient query execution. Use proper join types. Selecting the proper join type, such as inner join or left join, ensures that the query retrieves the desired data while maintaining the integrity of the relationships between tables. By aligning the join type with the specific requirements of the query and the nature of the data, users can accurately capture the desired result set and avoid unintended data explosion or duplication. This is the syntax for SQL join. We are selecting all rows from the customer table and joining the orders table with the condition customer's ID. And we can see from the results that the matching records from customers table and orders table are joined together.
Now, we will talk about the first type of join, the inner join. An inner join combines rows from two tables based on a matching condition, returning only the rows where the join condition is met in both tables. In SQL, the inner join clause is used to combine rows from two tables based on a specified condition, typically expressed using the on keyword, which specifies the columns from each table to be compared. This syntax allows the user to define the criteria for matching rows between the tables, facilitating the retrieval of relevant data that meets the specified join condition. Here is the basic syntax for the inner join.
In this example, by performing an inner join between the orders and customers tables using the customer ID column as the join condition, you can retrieve orders alongside with the corresponding customer information where the customer ID matches between the two tables. Customer table and order table are being joined. We're selecting the order ID from orders and customer name from customers. The inner join clause is used to join the tables based on the condition customers customer ID is equal to orders customer ID. This means only the rows where customer ID matches in both tables will be included in the result set.
Next up is the SQL left join. A left join ensures that all records from the left table or table 1 are included in the result set, regardless of whether there are matching records in the right table or the second table. This allows users to retrieve complete information from the left table, while still incorporating any matching data from the right table if available. With the left join, you can merge data from two tables, guaranteeing that all records from the left table are present in the output, regardless of whether they have corresponding matches in the right table. This approach facilitates comprehensive analysis by retaining all relevant information from the primary table, even if there are no associated records in the secondary table.
In this example, in the left join between the customers and orders table, all rows from the customers table are included in the result set, regardless of whether there is a matching row in the orders table. Rows from the orders table are also included, but only those that have a corresponding match in a customer's table. If there's no match, null values are returned for the columns from the orders table. The customers table is the left table and the orders table is the right table. We select from columns customer's name, order ID, order date. The select join clause is used to join the table based on the condition. Customer, customer ID, orders, customer's ID. In a left join, all records from the left table or customer's table are retained regardless of whether there is a match in the right table or orders table. If a customer doesn't have a corresponding order, the columns from the orders table not with null values in the result set, indicating the absence of matching order information for those customers.
And congratulations! We've mastered the SQL inner join and left join.